All right, we're back. And we're back so soon because I decided to do a different method on this one. I'm not going to do the full circuit check as I usually do. Two reasons. One is this particular radio was listed as working. Now that can mean anything, but one has to have a little bit of faith in eBay advertising. And the other thing is, this thing is so bloody small and cramped that it's incredibly difficult to get to every single point to test every component individually and also to test every connection individually. So what I've done is I've replaced three components, just three. These guys. Now let me tell you what they are. This one here is the all-important coupling cap. It couples the signal from the preamp tube, at which point you have high voltage, to the grid of the power amp tube, which is supposed to be low voltage. So if this thing is leaky, you can get excessive current through the power amp, overheat that, or blow the output transformer. So that's the first thing you change. This one is completely melted away, and as you can see, the lead actually came off the minute I put some heat on it. And this was across the 220 volts power supply. So this should actually be replaced with a safety cap. I've replaced it with a normal film cap, and I'll explain why in a second. And then this guy, this is an odd one. This one is one that connects the antenna. There's a little latch that you can switch in or out that connects in the antenna to the power line. Yep, that's it. This thing connects the antenna, or rather the power line, to the antenna. It's a 50 picofarad capacitor, high voltage. And the idea here is that you can actually use the power line, the mains cord, and possibly the entire power network as your antenna. That used to be quite common, but hey, again, should be a safety cap. Hasn't been put in as a safety cap. I put a micro one in there, and I will tell you what my thinking is in a minute. The first thing that I want to do is determine whether this thing works. So I have done those replacements which I consider to be crucial, try and avoid any major blow-ups, and I think using the dim bulb limiter and isolation transformer, I think we're safe enough to actually give it a go. Let me show you what I've set up so far. This thing is magic. This dim bulb limiter allows me to put in one light bulb, 40-watt light bulb. That's the only one that's switched in at the moment. The others are off. I can put in these others in parallel to allow more current to go through. But with a 40-watt light bulb, I've got maximum current restriction. I have it on limit. I can bypass, but I have it on limit. I have it off. I can actually switch it on because the switch on the radio is off. So I can switch it on. It allows me to see what voltage the load is seeing. At the moment it's got 232 0 amps or 0 milliamps. And I've also got it on safety mode. And that just means that it's completely lifted from ground and it's going through the isolation transformer. If I push this down, I can actually connect the earth, the mains earth, but I've got it floating, and this one here is to bypass the isolation transformer, which is not bypassed at the moment, so we've got full isolation. And as far as that's concerned, we're ready to go. I've also wired in the speaker connections. If you recall, one of them was there to that point on the output transformer. The other one goes to ground over here. It's connected to this so that I can very easily just bring this speaker, just a crappy speaker, in and out. So I've got it all ready. Everything seems to be okay. What I expect to see is the dim bulb, that bulb that I've got active, just flashing on and then going off. And I'm going to switch the radio on. It switches the volume control, so it's on the left, there's a switch. Here we go. Okay. Right. No sparks. And we've got 210 volts drawing 80 milliamps over here. The lamp is practically off. And we're hearing some noise. Well, the noises are positive, meaning it sounds like a radio and it's on long wave. The ferrite antenna is obviously active, and also I have the external antenna connected at the back, and let's see what we get. Volume's on max. Looks like it's trying. I'm going to give it another light bulb. We don't have shorts obviously, so it's now gone to 214 volts drawing 130 milliamps. It's making the right sounds. Well, sweet bugger all on long wave, but that's not too surprising at this time of the afternoon. Let's try medium wave. Ha! It's trying again. Too hard. Bloody hell, nothing. I expected something there. Alright, but it's working. The oscillators are working, at least. Let's try FM. And for FM, I've got 212 volts. I'm going to give it another light bulb. Reduce the current limiting. It's now at 224. So let's see what we get. FM, here we go. It's the other. Ah, brilliant. We've got something. Bring the speaker close. Lots of hum. But it's picking up something very, very faintly, but it's actually clear, but very faint. Lots of hum, obviously, so the filter capacitors need changing. Here we go again. I can hear it. I'm not sure if you can hear, but it's actually picking up quite clearly, but very, very faintly. This is on max. The tone is on max, so we should get the best sound, or most sound. Okay, it's working, but not much out of it. And actually, I'm not too surprised. The only capacitors I've changed, well, I've actually only changed one in the audio path. So I expect we'll get some more joy when the caps are all working. I'm going to just see what B plus is at the moment. Let's see. It's on DC volts, and I'm going to measure between the chassis and that point over there, which comes out of the selenium diode. Don't want to short anything here. Let's get this more secure. So, negative to the chassis, and this thing's going to go to there. 231.5 volts DC, 231.5, 230. I'm not sure what the schematic says, but it sounds about right. And that's on FM. It'll change slightly on AM. Let's see, on AM, on one of the AMs, 238. Okay, so between FM and AM, it does change slightly because on FM there's more current draw. Now let's see what AC ripple we've got on there. Oh, nearly 6 volts. Okay, so the filter caps are really not doing their job. Nearly 6 volts of AC ripple on that DC, which means we need to replace the filter caps. But the radio is working. It's giving us something, and when it gives us something, you can only improve. You should only improve. When it's totally silent, it's a real bummer because it could just be a loose wire, a solder connection. It really is a pain in the butt to trace when you don't have anything. When you've got something and you know you've got a whole lot of capacitors to swap out to improve the sound, you've got a starting point, and that's what we hope for when we switch one of these things on for the first time. Actually, the first thing you hope for is that you don't start a fireball. The second thing you hope for is that you get some radio out. And we have achieved both of those. While I was looking at the nest from which I had to remove this particular cap, and I'll give you the honor of that shortly, I often sit and just look at this thing, and the dirt annoys me. So I started cleaning this, and I know it sounds crazy, cleaning a radio before you know that it's working, but I suppose it does show a certain amount of optimism. I honestly believe that with the number of radios I've restored and repaired, I might regret saying this, but I'm not afraid of these anymore. I know that I can get them working somehow. So I decided to do the cleaning, and cleaning of the top, because that's the part that was most obviously dirty and full of all sorts of grime. And it cleaned up very, very well. There's absolutely no rust. Everything is just some dust and so on. These components here haven't been cleaned because I'm going to be removing capacitors there. But everything else was cleaned with isopropyl alcohol, cotton swabs, brush. I use one of these brushes. These are the natural bristles. They're a little bit rougher. And so what I do is I dip it in isopropyl alcohol and you brush away. And once you finish brushing away, you take a bit of this and you clean it up. And this is just, yeah, it might sound strange. You take these things, cut them up. These are the makeup removal pads that people get in the supermarket. Took a chopstick, cut it there, put a bit of a spring on there, and then it's just a question of, fitting it in here. Fitting it in like that, and then you can tighten it. And you got yourself a cleaning pad. And the reason I use these is because I go through a hell of a lot of this stuff. I mean, to clean this top, if I was using, cotton buds, these things, I'd go through packets of them. And these things are plastic. And I must admit there is a part of me that's a little bit environmental conscious, so I don't like messing that up. So anyway, the cleaning was done. I'm happy with the result, very happy with the result. These IF transformers clean up very, very well. Everything is very, very clean now. The tubes have been cleaned, and I'm really, really pleased with how this thing's coming out. This thing is, well, I won't say immaculate, but damn near it. Now I just need to get the function to match the look, because a great looking radio is bloody useless if it's not working well. I'll report back when I've done more recapping. And that could take a while because this bloody recapping is a slow job. I'll show you the inside. I'll show you where these caps came from. That one at the top was peanuts. That's really easy. Very accessible, easy to remove, not a problem. That one came from there, and it's been replaced with this black silver mica cap. Again, not a problem. The third one was a real little bugger. It's down there. That's that capacitor. And it came off one of the pins of this tube, and it went to one of these pins here, just top here. So some of these resistors had to be removed just to make the whole thing more accessible. Then you've got to put them back, make sure you don't forget anything, make sure you don't break any of the resistors. The danger with messing with these resistors, these aren't the worst, but if you put too much heat on the ends, they can actually come off. So you take a perfectly good working resistor and you just mess it up. So you've got to be very careful that you don't do more damage than good when you swap out these components. And as I said, that's one capacitor. There's probably close to an hour. I'm either very slow or this is really hard work. Probably close to an hour just to get that thing done. The idea is do it slowly, one bloody step at a time. Don't rush it. If you rush it, you're going to mess things up. There's one other thing to be careful about in these sets. The so-called lead dress. In other words, the way the wiring is done, where the components are in relation to others, where the wiring goes past, that can create a nightmare of isolations and noise. So if you move components from where they're originally placed, you run the risk of creating noise, creating an oscillation that takes a hell of a long time to find. So when you move components or you move wiring, try and put them back where they were. The reason they are where they are is because somebody found it worked that way. So try not to mess with that. And anyway, there are a few more caps over here. Not many, thankfully, but I see one over there. I see a electrolytic over there. There's another electrolytic here. That one's thankfully quite accessible. That one down there looks like a polystyrene. Well, it's off the camera. It's at the back there. But where else we got? We've got a couple of polystyrenes down there. There's one here, which is easy to get out. A few more polystyrene ones. Those are fine. There's one in there. A couple down here. There's another. What is that? Oh, there are a couple of those. Oh, sherbet. Okay. Yep, I can see some that are going to be a nightmare. But anyway, might as well stop complaining and get down to it. One thing to be careful about are these coils. Now, these wires are very, very fine. You can just see that. And you can very, very easily break them or desolder them inadvertently, and they become a real pain in the butt to sort out later, because sometimes you just can't see these bloody things. So even passing a brush over here, just cleaning it, you can actually break the coil wire. And you can check for continuity later, but it's always a pain in the ass. So the idea is avoid it if you can. Take your time. You'll save time later, believe me. Right. Oh, and the filter caps. The filter caps that are creating that hum, well, I believe it's the caps, are in this thing. And it's got two caps, the two wires coming out. They're both 50 microfarads at, I think, 350 volts. And they share a common ground. So the ground is obviously making contact with the chassis over there. And these wires then go off in that direction. What I'm probably going to do, I mean, I could restuff this. I'm not going to leave it there, obviously, but I probably will put two separate capacitors here, exactly the way that TRX Bench did his. There's quite a bit of space over here, unusually. Put a couple of caps on here and cut those wires, and then just connect those wires, the same wires that are already running down there, probably done with quite a bit of care. I'm not going to mess with that. I'll just put the new ones there, and hopefully we'll have the hum sorted out. And I know we're taking up more space in a radio that's got very little space, but this space is there. I'm going to use it. Now, about the transformer, I have a possible solution. I found this transformer in the stockpile. I don't call it junk box because I keep all this stuff. And this is actually a Telefunken. It actually has the same sort of paint job that this one does. It's the same width, but it's the same width there. It's slightly deeper, and I think I may be able to fit that there. But I need to test this transformer. I know I've played with this before. I don't remember what I used this for. That's the problem with messing around with stuff and not recording it. I hope this works. I'm not sure where I got this from. I believe there was I think it was a Grundig that had a blown transformer. So this probably is not it. I don't remember where I got this from. doesn't matter. I just hope it works. If it works, and if it fits in the box, in the cabinet, which I need to test later, I may move this, swap over that transformer for this one, and then I will have a full isolation transformer, a proper power transformer with 230 volts out, which is what this thing needs because it's using the mains 230 volts at the moment, and also with a 6.3 volts AC for the heaters and the dial lamp. So this thing could be a perfect fit, and it actually, because it is a Telefunken, it actually looks good. It'll look the part if I put it in there. Everything is error correct, or practically error correct. Brand correct. Now we'll just see if it's size correct. I'm not going to do that until I've got this thing completely done. When I finish the restoration and it's working perfectly, then I'll make a decision as to whether I change that out. And the reason is, if this thing works really, really well, and I want to use this as my personal radio in the office, because I don't want to put big things down there, then I will swap it out. If I decide this thing's not going to be in daily use, I might just leave it as is. I'll put an indicator here which tells me when the live and neutral are reversed for safety's sake. I've done that before, and it just lights up a little red lamp, red LED, to tell you that there's danger and you've got to swap it out. Basically just move the plug and swap the plug around. But I'll make that decision later. And the reason I used simple caps like this one and not a safety cap is because if I do change that over, this thing's going to go. So this is basically temporary. The other thing is, down here is a diode. It's an AEG diode, and it's a bloody huge thing. And what it does is it takes the supply from here, goes in there, into the diode, out of the diode, and out here. And so I can replace this with a simple silicon diode, or if I do change the transformer, I need a full wave rectifier. I'll put that in place of that selenium diode that they have there at the moment. Now, let me show you something which just goes to show that, since we're on the topic of dangerous radios with, hot chassis and everything else, just to show you how brave these old engineers expect you to be. That connection point you have there, in fact, let me switch this off, because I'm not that brave. That thing you see there is the B+. It comes out of the selenium diode, up that red wire, and it then connects another wire in there, and that's your B+, 230 whatever. And that thing is not insulated, and it's about 5 millimeters away from this metal can, from the IF transformer. So the potential for added fireworks is incredible here. We definitely have to make that safer. I just find it incredible that we talk about all these safety regulations nowadays. We're sitting here with a bit of potential dynamite right in front of us, and it's working. So, yeah, it goes to show some of the safety warnings in the 50s were slightly different to the ones we have today. Talk about safety warnings. If you're messing with this stuff, this is now just to protect myself from some law firm. If you're messing with this stuff, make sure you know what you're doing, because if you are messing with this stuff, it is dangerous. It can kill you. And if you don't know what you're doing, watch the videos and let somebody else risk their life. Anyway, sorry. I don't know why I find that funny. Honestly, I don't. It's probably just relief from not having this thing blow up when you switch it on. I've got to get down to some recapping and stop the bullshit. And I'll see you again soon. Thanks for watching. Hope you enjoyed this.